Hello Legacy students, so today we're going to talk about the area of regular polygons, what you're going to have on you. You're going to want your pencil, calculator, and then your notes as well. So, parts of a regular polygon, you're going to want to write these down so when we talk about this kind of vocabulary, you're not like, huh, what is that? Well, here I have a pentagon. It has 5 sides. One thing we know about them is all sides are of equal length. So if this side is 5, all the other sides are 5. One other thing we talk about is a radius. The radius is the distance from the center to a vertex, one of the points on the shape. And then the word apothem. That's probably a new word. Distance from the center to the midpoint on the side. So right here where my apothem hits, it cuts that into halves in that regard. So let's find the area of a regular pentagon with sides of 4 inches. This is actually quite difficult compared to what you think it should be. What we're first going to do pretty much in every single problem is we're going to draw ourselves a triangle using the apothem and also the radius. Now I'm going to take that triangle out here. Now since I use the apothem, this is the apothem right here, and the apothem split this side in halves. This is actually 2 inches long, right? Now we need to have a little bit more of this triangle so we can find our height, because if I want to find the area of this triangle, because ultimately if I find the area of this triangle, I just multiply it by a bunch of times to find all the others. I don't know the height, because area equals base times height divided by 2. We don't know the height, but we do know the base. I can't use Pythagorean theorem because I don't have this side. So it looks like I'm gonna have to find myself a degrees here. How many degrees are in this pentagon? Well, I can probably find the interior angles, which was that n minus 2 times 180, so I got 5 minus 2 times 180. So I know there's 540 degrees available for all 5 of my angles. If I divide by 5, I get 108 degrees. So that means each of these angles right here, 108, 108, 108, 108. But now notice how this is not the full 108. 108 is all of this. This is only half of it. So this angle right here is technically 54, right? And then this is the side we're going to look for. You know what? I bet I can use trigonometry, sine, cosine, tangent, SOHCAHTOA. Yep, it's coming back. So let's label our sides. So if this is where my dude is standing, this would be O, this is A, this is H because this is my right angle right here. So it looks like I'm going to talk about O and A. So tangent of 54 equals my O side over my A side, 2. Tangent of 54, remember that's quick scientific calculator problem. That is 1.3764 equals x over 2. Looks like we need to cross multiply, so I get x equals 2.7528. So that is my height of my triangle. Now let's find the area of him. So I got area equals my base, 2, times my height, which we found to be 2.7528, and then divide that by 2. So the area of my triangle is 2.7528, because if I divide 2 by 2. So that's for just this piece right here. Just this little triangle. Well, let's imagine I would have another one right here, right? Number 1. This, if I draw another one, I'll have this will be number 2 as well. 1, 2, this is 3 and 4. out of 5 and 6 right here, 7 and 8, 9 and 10. So I have 10 of these little triangles. So I have to take my area of one of them, multiply it by 10, and I will get 27.53 inches squared for my area. It's taking a lot of stuff that we learned for trig and whatnot and applying it to a different problem. However, it's going to be nearly the same process for each kind of polygon we're going to look at. Basically, take a triangle, find the area of the small triangle, and multiply by how many there are. Let's take a look at number 2. Find the area of a hexagon with a radius of 9 inches. Radius of 9 inches means from my center down to a vertice is 9 inches. Well, it looks like we need to make a triangle here. Let's go ahead and make our triangle. Okay. Draw out my triangle over here. So this is 9. Don't know that. Don't know that. So we're going to have to find the degrees in my hexagon and how many in each angle. So I got 6 minus 2, because there's 6 sides to the hexagon, times 180. That is 720. Then divide that by 6 so I can find all of them. That is 120 degrees. So each of these guys, 120, 120, 120, 120. 120 degrees for all of them. So that means that this little angle down here is 60. I got 90 there, 30 there. Well, I could use trig, but I have to do trig twice, and that would take forever. But it is a 30, 60, 90 triangle, right? Yeah. So I can use my shortcuts that we learned about our trig unit, or our triangle unit. So I knew that the hypotenuse of a 30, 60, 90 was 2 times my short leg. So my hypotenuse is 9. My short leg has to be 4.5. And then I knew my long leg was my short leg times the square root of 3. So if my long leg, don't know that, but I know my short leg is 4.5, well, 4.5 times the square root of 3 is 7.79. So now I have found all the sides of my triangle here. I now can find the area of this triangle. You could have also used trigonometry. You would have gotten the same answers as I did. However, it's kind of quicker if you can do the 30, 60, 90 trick. So my area of my triangle is 7.79 times 4.5 divided by 2, and that is 17.5275. So that's the area of one of these little guys. Well, it would be 2 for each big triangle, so I got 2, 4, 6, 8, 10, 12. So I'm going to multiply this by 12 for each of my triangles, and I will get 210.33 inches squared for the area of my hexagon. And that's the end of this video. We'll take a look at one more problem in class together as well, but until then, see you later, Sabers.